to the countdown.
Tahniah! Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hi. Yeah, Teacher Im here in today's maths lesson. All right. Today we have Cikgu Zana, Cikgu Aileen, and Cikgu Hafsah. Are you a physics teacher? So hello everyone, and I hope everyone is doing good. All right. Today's lesson is on stationary points, and Cikgu Zana will be presenting. So later we will be giving you, like usual, a code. Okay, a code which Cikgu Zana will be giving 5 minutes within 15 minutes, 5 minutes, 15 minutes, 20 minutes, and at the end of the lesson. And the code will be used to help you get your credit point. Okay, you can go and claim the credit point, and the link that we are going to give you will be at the end of the class. Okay, another one is the attendance, the link for the attendance, and the links for the attendance we will give you at the end of the class, and it only will last about 30 minutes in the after the class is over. Okay, so I hope you all can be with us. Be a good student. Use good words. Use good profile picture when you are chatting, so that all of us we can show your chats. We can present your chats into the live stream, and we can all learn good new things today. Okay, so there, Cikgu Zana, angkat tangan Teacher Zana. And then we have our maths teacher Aileen, and we have the Puan Hafsah AYU, okay, a physics teacher. So wait for them. Physics starting their class already. So let's move on. Cikgu Zana, to you.
Okay. Right. Hello there. Thank you, Teacher Im. Right. Hi there, students. Good afternoon. Okay. Thank you for making it for today's class. Okay. There's 7 of us here. Hopefully more will be joining us. Okay. Right. Can I share the screen now? Waiting for the screen to be shared. For my slide to be shared. Okay, right. So today's lesson will be on application of differentiation, and I'll be talking on stationary points. But before that, okay, let me remind you again about our playlist. In this playlist, there will be a collection of the mathematics video lesson. Similarly, we have a playlist for the calculus video lesson. So feel free to visit our playlist. Besides this, we have the pre-U lesson collaboration. That is the playlist. Okay. We have the chemistry video lesson. That's full of video chemistry lesson. We have the biology video lesson. We have the physics video lesson, and we have our representative here, Madam Hafsah AYU. Okay. And last but not least, the account video lesson. So students, feel free to visit this playlist, okay, to do your revision. Okay, let's start with our lesson. Okay, we start first by understanding what are stationary points. Okay, let's consider a curve y equal f of x. Okay, observe the points on the curve. We have 3 points here, P, Q, and R. Okay, Right. These points P, Q, and R are called the stationary points. So why are these stationary points? Because at this point, the derivative or the gradient dy dx is 0. Okay, we can use dy dx or the derivative of fx is 0. So in other words, okay, if the derivative is 0, so the points on the curve are known as the stationary points. And the tangent lines at this point are parallel to the x-axis because dy dx is 0. Next, PQ are the extremum points and R is a point of inflection. So let me explain in detail what are the extremum points. Okay, so we call it local extremum points. We have the local maximum point, local maximum point. Okay, observe the stationary points B, C, D, and E. Okay, all these are stationary points because we know that at these stationary points, dy dx is 0. Okay, notice the point B and D. Observe. Okay, sorry, this curve, I have to say that this curve is only valid in the interval x1 to x6. X6, they are included, okay, because this is a closed interval. This is very important, meaning that this curve is valid within this interval. So observing the curve, all the points on the curve within this interval. Okay, now observe point B. Notice that the gradient changes from positive to 0 to negative. Similarly to point D, it changes from positive 0 to negative. Hence, point B and D are called local maximum point. While notice that point C, the gradient changes from negative to positive, negative to 0 to positive, and point D changes from, the gradient changes from negative 0 to positive. Hence, C and E are known as the local maximum point. Right, this point B, C, D, and E are also known as the turning point. So why are they called turning point? Because the curve changes its direction. Now, why B is called the local maximum point? Okay, notice that at point B, y2 is more than the values of y at the neighboring points. Similarly, at point D, y4 is more than the y values at the neighboring points. That's why point B and D are called local maximum point, okay, at that neighboring points. So similarly, observe point C. Notice that y3 is less compared to the values of y at the neighboring points. Similarly, point E, y5 is less compared to the y values at the neighboring points. Hence, points C and E are called the local minimum points. So are you clear, class? What does it mean by turning points? The gradient changes, okay, from positive to negative, and y is called local maximum, okay, because at that neighboring point, it has the highest value of y, and y is called local minimum point. At that neighboring point, the y value is the least, okay? Right, now, how to determine the local maximum and how to determine the local maximum and minimum points and how to prove that they are local maximum and minimum points. So at local maximum point P, observe here point B, it occurs when x equal A. First, to find the coordinate of A, you need to find dy dx and equate it to 0. Then find the double derivative and the value must be less than 0. Hence, it is a local maximum point. Okay, there's another way of proving that it's a local maximum point. We use the shape of tangent method. Okay, meaning that you have to sketch the shape of the tangent based on the values of dy dx. Okay, now we know that at A, dy dx is 0, so the tangent is a straight line parallel to the x-axis, and you choose a smaller value of A, okay, the left side of A, that's why it's A negative, meaning there's not a negative value, a smaller value than A, and dy dx must be positive to show that the gradient to show that the line has a positive gradient. Similarly, you choose a slightly bigger value of a plus, okay? So dy dx must be negative so that the tangent line must have a negative gradient. So notice the shape is a maximum shape. Okay, for the local minimum point, okay, to show that it's a local minimum point, notice that it occurs at x equal p. Again, you show that when you find dy dx, make sure you equate it to 0 to get your x equal p, and d2y dx2 must be positive. Or you can use again the shape of tangent method to prove that it's a local minimum point Q. Okay, notice that at point B, dy dx is 0, so the line is parallel to the x-axis. And choose a smaller value of B negative, okay, negative here. Okay, hopefully you can see, so small. So dy dx negative to show that the straight line has a negative gradient. Then choose a slightly bigger value of B. It must be positive dy dx. So this is the shape of the tangent line. Notice that it shows a minimum point. Okay, that's how to find the local maximum and minimum point.
Okay,
Next.
Teacher Zana.
Oh, I
Why don't
forgot.
you give them the first
Oh,
code?
I'm so sorry, students. I nearly forgot. Okay, the first code is a digit 8. Okay, students, 8, 8. So take down somewhere, write down is 8. Okay, 8, EIGHT. Okay, now next, we move on to absolute extremum values. Okay, notice that it only happens when the interval is a closed interval. Okay, so that we can have the endpoint. Okay, the endpoint here is point A and F. Okay, because it's in the interval. Okay, right. Now, notice that F is the absolute maximum point because it is the highest point on the curve. Okay, the highest point on the curve. So the absolute maximum value is y6. In other words, it's the highest value of y within in the interval. Okay, in the interval, y6 is the highest value. Okay, now notice that point C is the absolute minimum point because it's the lowest point in the interval on the curve. So we say point C is an absolute minimum point, but the absolute minimum value is y3. So notice that when we say absolute maximum value, absolute maximum value is the y value. Bukan the coordinate, just the y value. We look at the y value, but it must lie within this interval and it's a closed interval. It's very important because if it's an open interval, kalau interval is open, we don't have any endpoint because we don't know where is our endpoint. It goes to negative infinity. Here it goes to positive infinity. That's why the intervals are very important so that we can determine the absolute maximum, the absolute minimum. Okay. Okay. Just briefly how to find the absolute extremum values. We find the extremum point, and then we find the endpoints and compare the y values. For example, here, simple example, here the curve is continuous in the interval 1, 8. Okay, it's a closed interval, meaning that A and E are included in interval. And then we have the endpoints already given, the extremum point, so it's already given. So now we just compare the y values, okay? So comparing, look at the y value, the highest value is 4. So the absolute minimum value is 4, and the lowest value, which is the endpoint, okay, is 1. So the absolute minimum value is y1. Okay, you have to state y equal 1, yeah, the letter y. Or you can say the absolute minimum value is 1, sama je. Okay, right. Now, what happened if our curve is continuous for all x in the real number system, meaning that here the curve goes to infinity. Similarly, here the curve goes to infinity. Hence, we don't have any endpoint. So, meaning that we still have the absolute maximum value because it's still in interval 4, but there's no absolute minimum value because we cannot tell what is the endpoint, because it's going to infinity. Hence, there's no endpoint to state, okay? Right, there's just a brief revision on how to find the absolute extremum values. Okay, next we continue point of inflection. Okay, so what is point of inflection? Okay, a point where a curve changes from concave upwards to concave downward is known as a point of inflection. For example, here, from interval AB, the curve is concave upwards. From B to C is concave downwards. So at B, the curve changes its concavity. So at B, it is the point of inflection. Okay. Now, a point of inflection can also be defined as a point on the curve at which the tangent to the curve crosses the curve, like this. It crosses the curve, okay? So that's the B is another way of defining the point of inflection. Take note, you can also find the point of inflection because there always exists a point of inflection when there's a curve consisting of minimum or maximum point or vice versa. There will be a point of inflection. And also, we can also tell by the curve if the curve is concave upward if it lies above the tangent line, and concave downward if it lies below the tangent line. Okay, that's how we memorize concave upwards and concave downwards. But mathematically, we have a proper system to show the point of inflection. For example, here we have a point of inflection. Okay, it satisfies the condition the derivative at point A must always be 0. This is the first characteristic of point of inflection. Next, to show that it's really a point of inflection, the first derivative has the same sign for all x near A. Okay, for all x near x equal A. Okay, whether it's negative or positive, it has the same sign, the first derivative. Or you can use the second derivative. Make sure the second derivative changes sign, either from positive to negative or negative to positive. This is to show that the concavity changes sign. Or you can show that the triple derivative is not equal 0. Okay, you have three ways of proving it's a point of inflection. Now, what happens if the third derivative is 0? Then we have to use the concavity method. That is, you have to show that the double derivative changes sign. Okay, right, that's a three method to prove that it's the point of inflection. Okay, now let's do number 1. Hopefully all of you can see. Right, we have a curve y2 cosine x plus sine 2x in the interval from 0 to pi inclusive is included. Okay, so given point P is and R are the extremum point. Okay, from the graph you can tell which one is local maximum, which one is local minimum, and point Q is a point of inflection. So our task is to find the coordinates of the local extremum points and the coordinates of the point of inflection. Next, state meaning that there's no working the interval where the graph is concave upwards, and state the absolute minimum and absolute maximum values. Okay, let's do. Okay, right. So first we need to determine the coordinates of the points of local extremum. Okay, now, so what must we do? Okay, we need to find dy dx and equate to 0 because we know that at local extremum point, dy dx is 0. We know that the local extremum point are the stationary points. So at stationary points, dy dx is 0. Okay, shall we differentiate the function to cosine x? It's been closed by the logo there. 2 cosine x plus sine 2x. So the derivative of 2 cosine x, okay, what is it? Okay, is minus 2 sine x. derivative of 2 cosine 2x, the derivative of sine 2x is 2 cosine 2x. So we have a double angle here, cosine 2x. Now, which formula are we going to use? Okay, for the cosine 2x, here I have divided by 2. Okay, so I already get rid of my 2. So now I need to change my double angle. So I'm going to use this formula. 1 minus 2 sine squared x. So substituting the double angle formula of cosine 2x, okay, and then rearranging it into a quadratic in terms of sine so that we can factorize easily. Okay, 2 sine x minus 1 multiplied by sine x plus 1 equal to 0. Okay, now, so we have the first one, the first factor, sine x equal half, and the second one is sine x negative 1. Now, sine x equal half is pi over 6, 5 pi over 6. We know that the first and the second quadrant here are positive. Sine x is the third quadrant. Okay, now, can we accept this? We have to reject it because it lies outside the given interval. Okay, it's raining cats and dogs, guys, so please bear with me. Hence, we reject 3 pi over 2 because it's outside the given interval. So now find the y value when x is pi over 6. So just substitute into your y. Okay, press the calculator. Make sure the mode of your calculator is in radian form because this is in radian form. So we have, or if we memorize in set form, cos pi over 6 is set 3 over 2. Sine 2 pi over 6 is sine pi over 3. So we have set 3 over 2. So this is set 3 plus half set 3. That's why we get 3 over 2 set 3. Okay, you can leave your answer in terms of set or you can leave in terms of decimal values. But make sure it's at least for significant figure. And then when x is 5 pi over 6, just substitute and press in the calculator. So you have negative 3 set 3 over 2. So from the graph, you don't have to show that it's point of a local maximum or local minimum because it's already stated it's extremum point. But you need to mention from the graph, okay, P, dia nak coordinate saja. So P is pi over 6, 3 over 2 set 3, and R is 5 pi over 6, 5 pi over 6 negative 3 over 2 set 3, okay? So make sure you state from the graph. So P is the local maximum point and R is the local minimum point. Okay, next. So we have find the coordinates of point P and Q. Next, we find the coordinates of the point of inflection. Okay, at point of inflection, remember d2y dx2 is 0. So you need to differentiate this the second time. So minus 2 sine x is minus cosine x. 2 cos 2x is minus 4 sine 2x divided by negative 2. We have cosine x plus 2 sine 2x. Substitute sine 2x as 2 sine x cosine x. Okay, simplifying and then factorizing, taking out the cosine x and then equating to 0. We have cosine x equals 0. So x is pi over 2 and we have sine x negative 1 over 4. So your x is 1.08 pi, or I change this into decimal form, 3.394 radian. Again, we reject this because it's outside the interval. Hence, okay, although we know that Q is at the x-axis, the y is 0, but you have to show because the question state determine. So we have to show the calculation to get the y coordinate, which is 0. Okay, you have to show. Since we are not proving that the point is a point of inflection, we are referring to the graph. Okay, so point Q is pi over 2, 0. Point Q is the point of inflection given in the question. Okay, next, state the interval where the graph is concave upwards. No working students, just understanding. Okay, Cikgu Faiza is in the house. Assalamualaikum, Cikgu Faiza. Okay, Right, just understanding the concept. For concave upwards, the arc lies or the curve lies above the tangent line. So you look at this curve, okay? So this is your tangent. It crosses the point of inflection. Here, the curve lies above the tangent line. Similarly, here, the curve lies above the tangent line. So it's concave upwards in the interval pi over 2. Okay, it's open because when pi over 2, d2y dx2 is 0. To show that its concavity upward, it must be greater than 0. But why here pi is closed? Because it's still concave upwards. If you are not certain, you can find your d2y dx2. Notice that it's a positive 2. Okay, so make sure when we state the interval, try to identify whether it's open or half open interval, okay, or half closed interval. Okay, next. The last one is very easy. This is just to test your understanding on the absolute minimum and absolute maximum values. This is very simple. Okay, you can straight away state without doing any calculation, without comparing any y values. Okay, yeah, my laptop's laggy. So from the graph, notice that the points are already stated there. It's missing. I'm sharing, but it's missing. What happened? My PowerPoint is missing. Yeah, can I share again?
Sure.
Okay, it's missing. My PowerPoint just disappeared. Tapi situ
While
stop
waiting,
sharing.
we can give the second code.
Yeah, the second code is 5. Students, the second code is 5. Okay, so we have
And
the two codes.
the
Why
second
it's
code
not-
is 5. And while waiting for Cikgu Zana, let's have a look at what you can get from your credit points. Let's go on and see.
Wow, banyaknya hadiah menarik menanti anda.
style pakai ramai dia kata.
Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma.
Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.
Cikgu Zana, can you share? If not, I will share.
Yeah, I'm already sharing. Okay, is it there? Yeah, okay, right.
Okay.
Thank you. It's laggy still. So from the graph, the absolute maximum or minimum value, we can tell. So first we look at the minimum value is at the bottom of the graph. So just take the y value, negative 3 over 2 set 3. And the absolute maximum value is set 3 over 2 set 3, okay? Just comparing the values on the graph itself, okay? Now we look at question 2. Okay, we have the function y equal x cubed e to the power of 1 minus x. Okay, it's lagging still, okay. So first we need to find dy dx, okay. So remember how to differentiate the exponential function. And we differentiate x cubed using the product rule, so we have this. Okay, now I'm using just dy dx to show that it's a stationary point and to determine its nature. So at stationary point, dy dx is 0, so we equate to 0. Okay, so we have x equals 0 and x, and so when x is 0, y is 0. When x is 3, y is 27 over e squared. Okay, just substitute here, okay? But then here, notice that e to the power 1 minus x cannot be 0, it's always a positive value, so we can ignore, okay? So the stationary point, the coordinates of the stationary points 0, 0, and 327 over e squared. Now we need to determine its nature. So I'm going to use dy dx. Okay, the first testing, dy dx. My laptop is laggy again. My laptop is laggy, Teacher Im.
Then I will share.
I'm out, is it?
Yeah.
What happened? Something
Now
wrong with my internet.
I will share so that we can save time.
Okay, share please. Sorry. I'm so sorry. Terkeluar.
All right.
Okay.
Number 2.
Yeah. Ya, sekejap ya. Saya nak masuk.
You can use
Okay,
from
now.
my slide.
I'm using. Okay, right. Okay, thank you.
All right.
Hey, what happened? Okay, now. So okay, next please. Okay, now we're going to prove the stationary point. So next, Teacher Im. Next slide, please.
I'm doing too much. Okay. Because once you have too many
okay.
on,
So,
also you will be laggy. Okay.
See. So I have
Is that?
going to use my dy dx testing. So dy dx for point inflection must have the same sign, and the local maximum point must have a different sign. Okay. Okay, I think it's missing here. It's missing.
You just say next, then I will move. Every time you say
Okay,
next, I will press once.
Okay. Yeah. Okay. Next. Okay, now there's the dy dx testing. Okay. So when x is 0, notice that we have same sign, the shape of tangent. Okay, now here is very important. A1 minus x is always positive. So we only look at this value 3x squared minus x cubed. Okay, students. So choose a smaller value of 0. So you can choose negative half. And when you calculate, the dy dx is always positive. Okay, so this is the shape of tangent. So here, choose a slightly bigger than 0. Choose half. Again, you will get it to be positive. Since the dy dx has the same sign, so point 0, 0 is a point of inflection. Similarly, x equal 3, choose a slightly smaller value than 3. You can choose 2.5, it's positive. Choose a slightly bigger value than 3, choose 3.1 or 3.2, the value is negative, and it has this shape that shows that is a local maximum point. Okay, next, Teacher Im. Next, Teacher Im. Okay, here you can use the alternative method, which I do not recommend because it's a very lengthy. You notice that our dy dx here, d2y dx2 is very lengthy, d3y dx3 is very lengthy. Okay, it's very lengthy. It's not difficult, it's just tedious. Okay, next, Teacher Im. Sorry, I'm going very fast because okay, yes, Teacher Im, next, please.
Trying to.
Okay.
All right.
Okay,
it's going
now.
very slow.
Okay, so here, after finding stationary points which I've shown earlier, so to test whether it's a point of inflection, you need to find d2y dx2. Our d2y dx2 is here, substitute x 0. So everything is 0 here. So e multiplied by 0 is 0. Betul lah, d2y dx2 is 0. Next, d3y dx3, which is 6e, substitute x0, we have 6e, which is not 0. So 0, 0 is the point of inflection, okay? Next, to show that it's the local maximum point, so we find d2y dx2, substitute x equal 3, okay? So notice that when we substitute x equal 3, we have negative 9 over e squared. Okay, students, if you do not like the e here, you can always convert it into decimal value. Remember, e is 2.718 something, okay? So the point 327 of e squared is the local maximum point. Okay, the whole point that I'm showing you this method is that you have to think of a way which method suits you, okay? Whether you like the single dy dx testing or the d2y dx2 testing. Okay, let's look at the next example, Teacher Im. Next example. Okay, here, this is a simple function. Hence, I'm going to use d2y dx2 to show the, to determine the nature of the stationary point. And I'm going to use d3y dx3 to show there is an inflection point. So we find d2y dx2, d3y dx3. Okay, students, I'm so sorry. Can you please look at the working? Okay, because something wrong with my laptop. Okay, right. So I managed to find d2y dx2 for you. I managed to get d3y dx3 for you. Hopefully, you'll get the same answer as mine. Okay, next, we move on. We need to find the coordinates of the stationary point. Next slide, Teacher In. Today, my job is easy because somebody is controlling my slide. Okay, so at stationary points, dy dx is 0. Just press, okay. So we predict to 0. Your x cubed is negative 1 over 8. Hence, your x is negative 1 over 2. Substitute into your y. Okay. 1 over negative 1 over 2 is negative 2 minus 4 times 1 is 4 times divided by 4, yeah, is minus 1. So you have negative 3. So your stationary point, something is missing, Teacher Im, my stationary point. Press lagi. Press lagi. Okay, so my stationary points, what is missing there? Negative 3 is missing. Oh, dia lari, yeah, because Teacher Im is sharing from her laptop. So
Yes.
mungkin configuration lari.
It's going to be different because we are using different OS.
Yes. Okay, tak apa. So
it's negative
now
1 over 2 and negative 3, okay?
Yes, okay. So we substitute x negative half into d2y dx2. Notice that we have negative 24 here. So it means that the stationary point, yes, did you impress? The stationary point is, okay. Dia lari ya students, tak apa kan, boleh baca kan. It's a local maximum point. The important thing is the step, okay. Okay, the important thing is the step. Okay, next. To show part B. Okay, part B is to find the coordinates of the inflection point. Okay, again, by now students dah tahu at inflection point d2y dx2 is 0. So what is your d2y dx2? 2 over x cubed minus 8 equals 0. Okay, straight away you can find x as 1 over 4 to the power of 1 over 3. Okay, we have to simplify this into index form because the smallest base is base 2. We have 2 to the power of negative 2 over 3. Substitute, but I substitute as 4 to the power of negative 1 over 3 because you see later on, when I bring it up, is 4 to the power of 1 over 3 minus, okay, this 4 to the power of 1 plus negative 2 over 3, I get 1 over 3. Hence, 4, 1 over 3 minus 4, 1 over 3 is 0. So your point of inflection is negative 2, negative 2 over 3 and 0. Okay, so substitute into your d3y dx3. Okay, this is our formula. Substitute our x. So it's not equal 0. It must make sure it's not equal 0. Okay, students, if you do not like the index form, if you do not like the index form, you can write down in decimal form. Okay, 0.6300, but make sure it's at least 4. Here I round off to 4, it becomes 0.630. Okay, class? Both answers are acceptable. Okay, next we need to sketch the graph. Okay, next teacher Im. Okay, right. So we have the maximum point, we have the point of inflection, again, and we have the asymptote. How to get the asymptote? Notice that as x tends to 0, your y tends to infinity. So the asymptote is 0, x equals 0. Okay. So here Teacher Im dah cepat. So my information is first you get the maximum point. Okay. So and you draw and you sketch the curve. And then get the point of inflection, which is 2, negative 1 over 3. Next, you have to study the behavior of the curve at the asymptote. It's very important, okay? So here notice that as x tends to 0 plus slightly bigger than 0, our curve tends to positive infinity. And here clearly indicate as x tends to negative 0 to the left side of 0, it tends to minus infinity. That's why we have this curve. So and x tends to infinity, this is the behavior of the curve, your y tends to negative infinity. Now teacher Im, can you press to see the final shape of the curve? Okay, so this is the point of inflection. This is the curve showing that it tends to negative infinity as x tends to infinity. And please do not forget to label your graph. Okay, this is just introduction to a graph sketching because next lesson will be on curve sketching. Okay, okay, right. Next example. Okay, example 4. Okay. Right. Just now I'm showing to you how to use dy dx to prove it's a point of inflection, and then d3y dx3 to show there's a point of inflection. Now I'm going to use d2y dx2 for the point of inflection. Okay. So again, find dy dx. By now you should know how to differentiate ln 2x over x and use the quotient rule. V du dx minus u dv dx over v squared. So I have 1 minus ln 2x over x squared. Okay, sorry students, I'm going very, very fast indeed. But you can always refer back to this video, okay? d2y dx2, okay, I'm showing you all the steps. So you have 2 ln 2x minus 3 over x squared. Okay, so you have find dy dx, d2y dx2. Okay, I'll stop here because I'm just going to use d2y dx2 to show there is a point of inflection. Okay, next teacher Im. Next slide, teacher Im. Okay, so first we need to find the coordinates of the turning point and determine its nature. So turning point again, by now standard procedure, dy dx is 0, and then find 2x is e. Remember, converting ln to index is e to power 1 is e. So x is half e. You can convert into decimal if you want to. Substitute x half e, you get 2 over e, and convert to decimal, up to you. Okay, doesn't matter. So substitute into d2y dx2, notice that it has a negative value. So this point is a, what point is it? A local maximum point. Okay, can you press enter, teacher Im, to show there's a local maximum point? Okay, so this is the turning point, half e to over e, or this point decimal form, and it is a maximum point. I forgot the word local maximum point. Okay, it's a local maximum point. Okay, that is question A. Okay, we already determined its nature. Okay, part B. Okay, part B, to get the point of inflection. So d2y dx2 is 0. Okay, so equate to 0. Again, the same process. Ln 2x is 3 over 2. So 2x is e to the power 3 over 2. So x is half e to the power 3 over 2. So you can change the decimal. Okay, up to you. Okay, so y substitute into here. Okay, ln 2x, tak perlu substitute x. Ln 2x here is 3 over 2. So straight away I put 3 over 2. Tak perlu substitute x here. Straight away 3 over 2. Okay, and then my x here, so I get 3 over e to the power of 3 over 2. So I'm to use the d2y dx2 testing to show is a point of inflection. Okay, now half e to the power 3 over 2, if we were to convert just now, is 2.24. So choose a slightly smaller value. I choose 2.0. You can choose 2.0. Substitute into your d2y dx2. 2.0. So 2 ln 4 minus 3 over 2 over 8, you get a negative value. Here memang must be 0. d2y dx2 at x half e to the power 3 of 2 is 0. Now choose a slightly bigger value because this is positive. So this is 2.24. You can choose 2.5. Substitute. Notice that it will give you a positive value. Okay, if you press your calculator, substitute 2.5 into d2y dx2 is a positive value. Okay. So I managed to substitute and I got it to be 0.014 something, okay? It's a positive value. So since d2y dx2 changes sign from negative to positive, what does this indicate? Indicates that the curve changes concavity from concave downwards, negative means concave downwards to concave upwards. So this point is a point of inflection. So I have shown to you the three techniques of proving the point of inflection. One dy dx has the same sign. One d2y dx2 has a changes sign. One d3y dx3 is not equal 0. But for extremum point, it's just d2y dx2 either positive or negative or the shape of tangent. Okay, number 5. Okay, number 5 is a simple function, algebraic function, just that is lengthy. But this time, I'm showing this question whereby you're showing the point of inflection by finding the interval of the concavity, concave upwards and concave downwards to show that the point of inflection exists. So again, we find dy dx, okay, and then we find d2y dx2, okay, right? So we move on. So pressing, okay. So the theorem is that for concave upwards, d2y dx2 must be positive. For concave downwards, d2y dx2 must be negative. So here we find d2y dx2 positives. Okay, you can divide by 12. You have the factorization. Next, we do the number line. You can use the graphical method. Okay, the number line, the line represent the positive value. Okay, we need the positive value. So what is the interval? Surprise. The interval concave upwards from negative infinity to negative 2 or negative 2 over 3 to infinity. Okay, concave downwards. Okay, press another time to show that we want the negative d2y dx2 less than 0. Oh my god, dia tak jadi. It seems that the animation does not work in Teacher Im's computer.
Yeah.
Yeah, to show
What do you use? Do you use?
Disappear. Just
Wait.
press.
Cikgu Zana, you use WPS or what? Or
Mine is
365?
2000. Yeah, no, that's not 365. It's just a simple old computer, Microsoft
Okay.
Windows
Right.
2017.
All right, Cikgu
2000.
Zana, I think it's time for you to give us the third code.
What is what? Jap. Just now it was 0. The third code is 0. I'm correct, right? Yes. Yes, 850. Okay, 0.
Okay, 0.
Okay.
Right, so the third one, the next step didn't work, so we have to go to the next one.
This is
It is
negative.
kind of
This is
overlap.
negative. Okay, it overlap. Tak apalah ya. This is to show it's negative sign. So from negative 2 to negative 2 over 3. Concave downwards. Okay, next. Okay, so just now we have managed to find the interval where it concave upwards, it concave downward. So you have to find the value of x. So it could be 2y dx2 equals 0. So you have x equal negative 2, x equal negative 2 over 3. So pressing again, Teacher Im, press enter. Okay, when x is negative 2, your y is 10. When x is negative 2 over 3, your y is 14 over 27. Okay. So we have to deduce, but before we deduce, next, okay, we use this theorem. We already managed to find that the y concave upwards in this interval, concave downwards in this interval. So meaning that it changes from concave upwards here to downward. Okay, so at x negative 2. And it changes from concave downwards to concave upwards to negative 2 over 3, 14 over 27. So from this interval, you can get the point of inflection. So meaning that you don't have to use the method that I mentioned earlier. By looking at the interval where it concave upward, concave downward, we can determine the point of inflection. Okay, class. Next. Okay, so next we need to find the extremum point. Again, at extremum point, dy dx is 0. So equate to 0. You have x 0, x negative 2. We reject negative 2 because this is the x coordinate of the point of inflection. So just substitute x 0. We have y equal negative 6. So the extremum point is 0, negative 6. And then substitute, tekan lagi Teacher Im. Okay, 0, negative 6 is the extremum point. So when x is 0, substitute here, clearly is 48. So 0, negative 6 is the local minimum point because this is positive. Yes, student, this is positive. Okay, good. So this is using d2y dx2. Okay, next, Teacher Im. Okay, sketching again. Okay, we already know the minimum point here. Okay, we already know the point of reflection. The behavior of the curve, x tends to infinity, y tends to infinity. Behavior of the curve, x tends to negative infinity. The y still tends to positive infinity. Okay, so press Teacher Im. So this is the shape of a curve, our curve. Do not forget to label your curve. Press another one. Okay. So make sure you label your graph in order to get the full mark. So D1 is for the points clearly plotted. Okay, D2 is the shape clearly sketched. D3, everything must be correct. The x-axis is labeled, the y-axis is labeled, okay? And the curve is labeled. Okay, next. Later on, I will explain in detail how to do curve sketching, the next lesson. Okay, next. Okay, number 6. Saya cepat ni, tak apa. Right. Here we need to find the interval whereby the function increases, decreases, and from the interval we need to state the coordinates of the extremum point. B, again, the same as question 5. Find the interval where it concave upwards, downward, and find the point of inflection. So B is similar to question 5, but 6 is different, whereby you find the coordinates of extremum point from the interval where the function increases and decreases. So this is the theorem again. When dy dx is positive, function is increasing. Remember the curve of, that I mentioned. When dy dx is negative, the function is decreasing. Next, concave upwards. Teacher Im, press enter. Okay, here, Teacher Im press cepat sangat. Okay. Okay, next, d2y dx2 positive means concave upwards. d2y dx2 negative means concave downwards. So students, you have lots of things to memorize for stationary points. Dengar macam simple, but lots of things to understand. Okay, can we move on? How to determine the coordinates of extremum point? Okay, so first find the first derivative for increasing function. Remember, this is positive, so when you multiply, it becomes x less than 4, okay? By now you should know exponential function is always positive. So for decreasing function, this one is negative, so x must be greater than 4. So what can we conclude? Function is decreasing in the interval negative infinity to 4 and decreasing from 4 to infinity. Press enter, Teacher Im. Okay, so decreasing from 4 to infinity. So sorry student, I hope you tengok balik lah ya. Function is decreasing in this interval 4 to infinity, increasing from negative infinity to 4. So what is the extremum point? Okay, next slide. So you have to find the f prime x equals 0, we have x equals 4. So substitute into the function, we have 1. Okay, so the extremum point is, Teacher Im? Okay. Okay, the extremum point is 4, 1. Okay, the question only asks coordinates of the extremum point. Dia tak minta the nature. So jangan buang masa cari nature. Okay, but I'm just testing you What is the nature of the maximum point for 1? I don't think we have time for the students to answer. Do we have time? So what do you think? The nature. Question only asks for the coordinates of maximum point, and we have answered the maximum point is 4, 1. But I'm testing you, what is the nature? You already proven decreasing to increasing, or say increasing to decreasing just now. The interval. So anybody would like to try? Just either local maximum or local minimum. Remember the interval for increasing function, decreasing function. Okay, we are running out of time. Tak apa, teacher A, we give them the answer.
Okay.
Okay, so 4, 1 is a local maximum point. Why? Because the function is increasing from negative infinity to 4. At 4, 1 is a stationary point. Then decreasing in the interval 4 to infinity. So 4, 1 is a local maximum point. Yes, thank you, Mei Ling. You have answered it correctly. Okay. Ziyi, maximum, well done. So sorry about the PowerPoint because it's raining cats and dogs here, so my computer is lagging. Okay, that's good. So we can find the maximum point using the interval of increasing and decreasing function, not necessarily BD to Y dx2 or the shape of tangent. Okay, next B. B ni macam question 5. Okay, B exactly the same as question 5. We need to find the interval. So for concave upwards, double derivative is positive. So you have to do the number line. So positive in this interval, x less than 3 or x less than 5. But make sure you answer in interval form. Okay, question asks interval. If we put like this, you will not get marks. Okay, because we need interval form. Okay, negative infinity to 3 or 5 to infinity. Okay, brackets, open interval. Concave downwards, terbalik saja. This is negative. Here the square box negative here. So f of x is concave downwards in 3, 5. Okay, open interval. Okay. So
We have about
exactly
3 minutes left.
Okay, move on.
We move on to the next one.
Yes.
Maybe.
Okay, so again, we find the value of F3, F5. So these are the point of inflection because it changes commodity of X3 and X5. Okay, class? Right. Now, number 7. 7 is straight away forward, easy. Number 7 is just finding the absolute minimum maximum value of the function. So step 1, find the stationary point. Okay, find dy dx. Okay, simple function using derivative of quotient equal to 0, x is 1. So you need to find the y value, okay? 5. X negative 1 we reject because it's not in the interval. Okay, next Stpm, we find the endpoint. Find the endpoint. So x0, y is 0. Just substitute here. X3, y is 3. Next, we compare the y values. Okay, up to you. You don't have to use the table. I'm using tables to show you the minimum y value is 0. So the absolute minimum value is 0. And the maximum value is 5. The absolute maximum value is 5. Okay, you can use 5 or you can say y equal 5, up to you. From the table, okay? Right, next, the last one. Okay, now we have x minus ln x, our function, but our interval is 1 over e inclusive. So again, find the stationary point. Step 1, x is 1. When x is 1, substitute 1 minus ln 1 is 0, so we have 1. Remember, we need to find a y value. Okay, next, find the maximum point. Yes, teacher, you are right. Find the maximum point. Sorry, the endpoint. Endpoint means the interval. 1 over e, we have 1 over e minus ln 1 over e, which is 1 over e plus 1, or 1.368. Okay, you press enter because I written there, okay, the e value here. So when x equal e, substitute, you got e minus 1. Ln e is 1 here, so 1.718. third step, the last step, but make sure students at least 4 significant figure. Okay, so what is the absolute minimum value then? Okay, we compare the y values. Okay, we compare all the y values that we have obtained. Okay, which one is the absolute minimum value? Can anybody say? Anybody? Absolute minimum value from the table and absolute maximum value. It's simple, just compare the y values. I purposely give you a simple question right till the end because you don't have to calculate much. Okay, anybody? Okay, tak apalah. Alright. Okay, tekan enter.
There's an answer from Hakim Fitri. He say maybe it's a max.
That was the previous question. I think
I
is
see.
lagging. Tak apa.
Right.
Anyway, the absolute minimum value is 1. And because from the table, 1 is the least value and 1.78 is the 1.718 is the greatest value. So the absolute maximum value is 1.718. Can you please press enter? Okay, right. So that's about all, students. I think I already trying to complete all about stationary points and extremum points and absolute minimum, absolute values. Okay, right. That's all. So sorry about the slides. Okay, that's it. All these technical problem, but I hope you can bear with me. Okay, that's all. Okay, next slide, Teacher Im.
All right.
Just to say thank you. Okay, thank you. Thank you. Don't forget to subscribe.
Okay.
Maybe your last digit.
Your
My
last
last
digit,
digit.
Cikgu Zana.
Okay, number 1.
The last digit is number 1, and therefore we have ended our class, and I hope you enjoy the class. Well, technically it is having thunderstorm outside there. All the teachers here are having technical problem because the internet is super slow, and then the thunderstorm is really hurting the internet. Okay, so that's why I'm laggy, Cikgu Zana is laggy, and Cikgu, although all of us are from different place. Okay,
Yeah, I'm from
so
Negeri Sembilan.
see, I just saw a answer popping out. You see?
Oh yeah,
See
so
how
slow.
laggy am I?
Yeah.
Answers are popping out, and students are actually answering your question, Cikgu Zana.
Yeah.
Well,
Okay, I'm happy.
very good. Yes, very good. They are answering the question, but now only we can see the answers because all of us are laggy. But anyway, thank you for being patient with us. So the 4 codes are already out. I'm not going to repeat because we are not supposed to repeat. And then the link CGL is already out. So the next thing that Cikgu Aileen, have you put down the link untuk for the students to register the credit? Yes, it's also there already. There's the link for the students to register their credit. Okay, that's for you to register so that you can get prizes. So remember this registration, you can take your time. You can do your registration for the class IU first because that is the sijil peringkat kebangsaan. You need 30 minutes from when the class ends, then it will stop. Okay, for this credit, you can take your time after that. Okay, next week will be Cikgu Aileen's class. Okay, next week will be Cikgu Aileen's class, and it is going to be what, Cikgu Aileen? Why don't you tell the students what? Optimization next week. Okay, so if you like our class, if you love us, please do hit like to Cikgu Zana's lesson. Okay, support us because the likes are supposed to be our motivation. You know, it's very tiring. PDPR is actually very tiring because we are all trying our best to get the best lesson out to you. Okay, PDPR for our students in school and including the students from the whole Malaysia. So give Cikgu Zana a like. She's actually a retired teacher, very experienced. So give her a like and do subscribe to her channel. If you have already subscribed, please tell us done in the chat box. Please, please, please. Okay, thank you. Bye. We will see you again
Bye.
next week for
Bye-bye.
our next class from Cikgu Aileen, Optimization. Bye.
Bye. Thank you, student. Love
Berita
you
baik
all.
untuk
You're
semua.
awesome. Bye-bye.
Kini Akademi YouTuber memperkenalkan sistem mata ganjaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.